Welcome to the NOC review from the 22nd C3 event in the BCC. My name is Stefan Woy, Sebastian Werner, sorry. He's also known as Blackwing, and normally I call him Blackwing. So, no, it's not Darkwing, it's Blackwing. Welcome all who joined us for a good hour. The talk itself will have about 40 minutes, and if there's any questions, suggestions, they are welcome. Ask during the presentation if something is not clear or you want to have some more information. First thing to start, we are only 2 people standing here. NOC itself has 16 people working on it. Some of them are in the auditorium, some standing on the side. We're very international, very European this year. We have lots of people from Amsterdam working in the NOC, and we have people coming from the US helping us with the wireless network. Thank you very much, and thanks for all the work you have done for us. Before we start, one question, and this is the thing which we ask us too, because we didn't get any feedback from the help desk we have invented this year, and they have said that they don't have much work to do this year. Are you happy with the network? Raise your hand, please. That's good to hear. After the last years, we have made quite some changes here, and let's begin with the agenda. We have a few points here. First, a recall of the 21st C3 from the last year. A technical requirements we have formulated for this year's event, uplink topology, network topology, traffic statistics, anomalies, and an outlook for the next year. There are some ideas what we could do better and some things we haven't implemented this year. And let's start with the first sketches. We have had unforeseen hardware problems last year. Let's call it the other state with some of the equipment we have had. And some of these problems came from late delivery of the equipment itself. Some of this equipment was broken, and lots of people have had lots of problems with the wireless equipment. It was one of the main problems last year, and we have a lot of problems with the high traffic load between the different levels of the building. Therefore, the decision was made, look for sponsors which can supply us with enough LAN hardware this year, very early. There were good talks there, and the last sketch will show us all the sponsors. I want not to bore you with this stuff right now. In-house LAN working, but very late. I think it was the 28th of December where we could say that it worked actually. Uplink worked quite well. It was implemented 2 weeks before the start of the event. It's around 600 megabit last year. And some, as most of you know from the last talk from last year. As I said before, wireless LAN was suboptimal. And one of the biggest problems last year was that you were not informed. We have worked on the network, and nobody knows what we are doing actually on the network. We tried to make it better this year, and as a summary of the last year, it worked, but it was not good. This is the setup we have had last year. You see the different levels. It's, from A is the tech center up to the D level, this magic D level at conference room 1, the gallery up there. We have installed there in the A and the D level the core switches. It's the same thing this year, but Sebastian will talk about later. And we have some stuff from Cisco there, switches in the B and C level. Missing here is the wireless LAN. Some people say it wasn't there. Okay, 77 VLANs, multi-gigabit backbone, and we have over 3,400 DHCP leases. I have also heard numbers of about 4,000 DHCP leases last year. This correlates very good with the number of people visiting us last year. I think I've heard numbers of about 3,500 people being here. 3,400 DHCP leases means everybody has a laptop or a device with a MAC address. Okay, what we tried to implement this year, where that we have high bandwidth in the whole building. In every outlet, you should get a minimum of a 100 megabit port. Actually, you get gigabit ports at every copper port in the building. And the VLAN, especially for the lecture rooms, should work. And we have tried to make a very simple and redundant setup, which we can control. No fancy stuff, no beta releases from vendors. Still, they're interesting to see this, how it works, this hacker community, and a lot of small packages doing nasty things on the boxes. And one thing we missed last year was native IPv6 connectivity. And we have done IPv6 this year right from the start. Maybe a little bit fakey after the IPv6 tutorial in room 4, I think, yesterday. Some of you tried it very hard to break it. Okay. Okay, let's switch.
Okay. In-house this year we have a 10 gigabit backbone, and this means this should be enough bandwidth for everyone. And we tried again to make many small layer 2 domains, meaning that you have less broadcast, less ARP traffic in all the networks. And of course we need then inter-VLAN routing and switching, because from one network to another you need connectivity. And so of course we need switching and routing devices, of course. And also we got multiple internet uplink providers providing us bandwidth, a huge amount of bandwidth. I mean, it's just more than entire Africa has, and so, okay. And yeah, another new thing is we got a new wireless LAN solution, but I will talk about that later. And we got hardware from various hardware vendors. So let's get to the in-house LAN. What we did there is we have for the access layer where you all plug in, it's ULOT packet 3400 CL switches having 48 gigabit ports. And they are all linked with 2 gigabit trunks to the HP aggregation layer switches. These just connect together all the access layer switches, and finally they are linked to the 10 gigabit backbone having Foundry Big Iron and HP 94 SL hardware. The interconnection between these backbone devices, these HP and Foundry, is done via fiber links. The routing, the inter-VLAN routing, is actually done by these big HP 94. This is what it looks like. You see, the cabling is, let's say, a little bit improvised and so not perfect, but it actually works. What you can see in the right-hand picture is that there are the 2 fiber links, and these are the 10 gigabit links. This is what the network actually is built from. You can see in the top level, D57, as last year, there's the main interconnection switch. Then you have for every connection room, you have 2 distribution switches. As I talked about, the HP 53, and down in the hack center at A85, you have another inter-VLAN routing switch. On the right side, you can see in 87 there's all the uplink hardware. We will talk about that later. So this is good a bridge for getting to the uplink, because the question is, how do we route in the local network? Many people asked us last year what exactly we did, and so this slide is for those people. All routers we have, as you can see, speak OSPF for the connected networks. So we distribute every subnet we have into OSPF and get therefore local routing information. But all the external routes from the internet get in via BGP from different providers. As you can see, we get the external routes. They get to all the routing devices. And so the routing decision, what is your next hop in routing, is done by your inter-VLAN switch, your first hop. Okay, let's come to the internet uplink.
That's a part I've done. it's quite difficult to get 20 gigabits of traffic, and it's not actually 20 gigabits. Some people told you that we have such a big bandwidth. It's true, if you look at the entrance to the building, we have 2 dark fiber connections, each with 10 gigabit. We are collecting in sum about 15 to 16 megabits traffic, but normally you can use from this 3 to 4 gigabit traffic. Actually, if you look at the aggregation of the routes, you did not get 10 gig out of it. What you have to do there, with socializing with carriers, a lot of events since January of last year, which I joined, like RIPE meeting and D6 meetings. So there's a lot of fun there. Somebody goes there, joins them. There are lots of interesting people running around. The second thing we have to do is to explain them that hackers are not evil. There are a lot of informations in the network, call it Google, where they say that these events that they're actually hacking. I want to remember the last year's event. I think was one of the Berlin providers, which has his. Correct me if I'm wrong. I think he has his password list on the website for downloading. Afterwards, he was a little pissed. Sorry. So there's some bureaucratical stuff. One of the providers has one piece of paper. I took a pen and signed it and said, okay, that's the 1 gig gigabit link. Another one sent me 30 pages. Each has to be signed in 2 copies sent back to Frankfurt. This one a little bit less. What we have also said is there are many people which work for us at the carrier side, and normally they have children, they want to go home, they want to have Christmas. Therefore, the uplink itself is set up before the event. We have this year the first IP uplink 1 week before the event starts, because during 23rd, 24th, 25th, 26th of December, you won't get anybody in second level support helping you if your BGP sessions are crashing or flapping. So as I said before, to uplink fibers, we can make this short. I've told you a lot of these things in advance. Enlightened with 10 gigabit. One link was possible to use with 10 gigabit because with the help of the people from Holland. And we have on one link the company called Versatel. Most of you know, they're a DSL provider in Berlin, working all over Germany. They supplied us with a native 10 gigabit link to their routing gear at the other end, and the rest of the second link was used to aggregate the different uplink providers. We have put all the uplink routers. It's a little bit different from the last year. We put the routers outside of the building and collected the traffic. The reason was that we tried to make a little bit of traffic shaping. There were only 1 gigabit link coming to the building, and some problem with the traffic. As you have seen, 600 megabit wasn't actually a problem last year, but we didn't know in advance so that we can shape traffic before it goes onto the fiber to the building. This year we have enough bandwidth to push all the traffic to the building. And therefore, there was a secret room in the last corner of the building. That was an A87, that's behind the Hexen room. There were a whole pile of equipment which terminates all the IP uplink. So you can say the BCC is some kind of co-location facility. Should have brought more servers. Okay, VLAN trunking. We have put all the things in Ethernet layer 2. There are not equipment like POSIP or SDH equipment. Most of the providers didn't use it anymore. Most of the people have now Ethernet equipment connecting all the IP uplinks over these boxes. So this is a more detailed picture from the left to the right. On the left side, you see the Versatel link with 10 gigabits terminating at Gradestraße 40, this co-location facility of Versatel. And then we have the Foundry boxes getting all the traffic from different vendors, as you see, from Lützowstraße, Netzeincoach, and D-Hosting. And we have also a second link to another co-location facility in Berlin called Albion Contour, where we have another gigabit sponsored by another company, where we have KPN, Eurorings, and Telia Sonera. Welcome to them. KPN, some of you who joined the camp, I think 3 years ago in Landsberg, know that we have